Hello, everybody. Welcome to our final part on design and detailing reinforced concrete diaphragms. As Maria had mentioned, there's that extra handout today. Those were the equations that I had meant to include on the slides 50 and 51 in the last part. So you have all of those equations there. Those equations are on other slides, but I wanted to include them all in one place so that you can see from that figure exactly what pertains to what. So given that, today we are going to do two numerical examples. We certainly don't have the time to go through it in detail, but I'm going to show you some of the highlights for both a 10-story building. It's assigned to seismic design category B, and also a 12-story building assigned to seismic design category D. I do have a lot of equations in this so you can see where everything comes from. We'll highlight some of the things I had mentioned so you can see some of the more key things to look for in these particular examples. Once again, everything that you see is going to come from the 2019 edition of ACI 318, as well as the 22 edition of ASCE 7. So let's start with our first building. It's a 10-story residential building located in seismic design category B. So since it is seismic design category B, we are permitted to use ordinary moment resisting frames, and those are indicated around the perimeter. You'll notice they don't continue down into this location, down to the base of the building. 9-inch slab, and all those beams and columns are part of the seismic force resisting system. Now, the particular loads that can be applied to this particular building are wind, seismic, and the general structural integrity loads given in section 142 that we talked about during our first session. It turns out that the seismic forces govern. And we're going to do a comparison between the diaphragm forces obtained from sections 12.10.1 and 12.10.3 so you can see exactly what the difference is. We're going to concentrate at the roof level. And we'll give you the forces over the whole building, but we're going to concentrate our design and detailing at the roof, where typically the force is usually the greatest. So the diaphragm is classified as rigid in both directions. We're going to use the corrected equivalent beam model to determine what our diaphragm internal forces are. And because we are in a building assigned to seismic design category B, we don't need to concern ourselves with any orthogonal load combinations. So we can apply the forces independently, as you can see in our example, in both the north, south, and east, west directions, find out our internal forces independently, and then design and detail for the more critical of the two. So this slide gives you a summary of the story shears and lateral forces over the height of the building in accordance with the equivalent lateral force procedure in section 12.8. So recall, we've got to compare this lateral force that we obtained from section 12.8 to the lateral diaphragm force determined by either of those two sections, 0.1 or 0.3, that we talked about a few seconds ago. So we're going to concentrate on the roof level, 98 kips up at the roof,